Okay, students, so we're here in Unit 6 in dilations. Alright, dilations, we're going to be talking about similarity, scale factor, a whole bunch of things. And what this really means is we're going to make things big or small. Okay, that's really kind of the summary of it. And you guys might have ever gone to the doctor and they dilate your pupils so they can see better in your eyes and just inspect them, so on and so forth. Here's a example of dilating, enlarging a tiger. A lot of cool stuff right here. And really, if I could sum up this unit in one word, multiplication. If you're good at multiplication, you're going to be really good at this unit. And that's specifically, if I can sum up it in 2 words, I'd say cross multiplication. All right, we're going to be setting up ratios, proportions, cross multiplying. That's basically a huge punchline of this unit. Not the entire thing, but a huge punchline. All right, so we're going to be doing dilations, but before we start into the new stuff, let's relate this stuff we've already been doing. All right, so remember, we had rigid transformations. All right, these translations, reflections, rotations, we had triangle congruence, side, 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 angle, 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 side, HL. All right, so we're going to be taking that stuff, building upon it, and making it a little bit different. All right, so just to warm up. All right, translate the image using the coordinate notation xy arrow, x minus 3, y plus 2. So translation, oversimplifying translation, it's adding, okay? And then x minus 3 means left 3, up 2. And you guys might hear my golden doodle in the background. He just now chose he wants to go outside, so just let him outside to go play. It's 5:19 in the morning. Hopefully he doesn't go bark at a leaf and wake the neighbors. Anyways, so now we're gonna go left 3, up 2 from every point. 1, 2, 3, 1, 2, boom, A. 1, 2, 3, 1, 2, B. 1, 2, 3, 1, 2, B, or excuse me, C. You guys might hear my black lab sitting on the couch with me too. He actually cares about transformations. And don't forget the prime notation, all right? The prime notation, that tells us which one we're at, all right? That was the first move, okay? Now we're gonna reflect over the y-axis. All right, the hardest thing about reflecting, in my opinion, is doing it over the right line. Remember, this vertical line is the y-axis. And then things are equal distance to the line of reflection. What do I mean by that? A is 1, 2, 3. It was 3 to the left, so A prime will be 3 to the right. 1, 2, 3. A prime, B prime, and C prime. What a beautiful reflection. The other day I looked at my reflection in the mirror, I looked away, started walking away, my reflection was still looking at me. It was kind of creepy. Anyways, and then the next one, we're going to rotate. This one's the hardest one. We have different kinds of techniques. We're going to rotate 90 degrees counterclockwise. So that's going to be just like that. And remember, we have these quadrants. So when you rotate, you're just going to move one quadrant. All right. So, what a time to be alive where I can almost just, not almost, I can actually just physically rotate it. We have the rules. We can rotate it on our iPad itself. Let's see. It's not going to work just quite that easy. It's going to be a little, there we go. That's about as good as it's going to get, probably. Actually, let me do something. But nonetheless, A should be at right there. B should be right there. And I kind of missed. I must have not done something perfect. All right, there's different techniques where you can physically rotate our iPad. I can't show that on a video, and types and other things. But why are these transformations called rigid? A, B, C. So the original triangle is congruent to triangle A prime, B prime, C prime. It preserves angle and side measure. All right. All the sides still have the same length, all the angles still have the same length, and that's why they're called rigid transformations. All right. In this next video, we're going to use GeoGebra to explore dilations.